In this section, we'll talk about blower door testing in the IECC for the IECC codes, and they really don't give any specific guidance to multifamily other than how you set up a building for single-family test. The biggest issue that you'll face is whether to test individual units with a blower door, or are you gonna test it all as one space. And if you're testing unit by unit, all of that leakage is going to be counted as leakage to the outside. So you'll need to meet that 3 air changes per hour in the 2012 code for each unit by unit. And if that works, you could certainly test it that way. So your possible options are you could test the whole building as one zone, and then you'd only be testing leakage to the outside. You could test individual units with a single blower door, which would count the interior leakage the same as outside leakage. You can do guarded tests so that all adjoining units are at the same pressure. Use multiple blower doors, keep each unit at the same pressure. So that would only measure leakage to the outside. Or maybe the local building official would let you use a ResNet sampling protocol for larger buildings. So testing every unit's not required. You'll have to talk with them about that because it's not specifically spelled out in the code, although it may be spelled out in your state. Your state may have rules that were written to state more specifics about how that test could be done and what your options are. So equipment options, you could use a blower door set up in an exterior door or a hallway door. You could use a blower door set up in a window in an apartment unit, individual unit. Duct blasters set up in a blower door frame, or duct blasters set up in a window. So the difference between some of those types of tests, if you have the duct blaster set up in a window and you're depressurizing, the blue arrows represent air coming into that unit from all spaces. So the unit in white in the center here is the unit that you're testing. This green area is adjoining units, and the longer green area is a hallway. So in this example, this white area will all be at 50 pascals, and all the adjoining units will be at something other than 50. They're not open to the outside. They're under normal testing conditions, and they'll be at some pressure other than 50 pascals. So really, if this is a middle unit of a 3-story building, you're going to have a pretty small surface area to the outside, and you're going to be measuring leakage of all the other sides. Now, it's not a bad idea to compartmentalize the units for odor transfer and for indoor air quality reasons, tobacco smoke transfer, those kinds of things. So it's not a bad idea to have a goal of compartmentalizing these units, and you will also there'll be more energy savings. If you've got a strong wind coming on that outside wall, there'll be less wind blowing all the way across the building and then out the other side. So there are advantages to compartmentalizing units, and if you can test them that way and they meet the standard, that may be a better solution. But we're just going to go over different testing options for what you can do. So with this method, you have a pretty small surface area to the outside. Adjoining units may be only depressurized slightly. So this is another method that's typically used, where you set up either a duct blaster fan. We do have a red nylon panel with a hole in it the size of a duct blaster. You can just use that in place of the big blower door fan. And these units should be tight enough so you can use a smaller fan. You could set that up in the door to the hallway, and And then again, air will be coming in from all directions. You'll be blowing air out of the unit, depressurizing the unit, and blowing it into the hallway. So the hallway will be at a positive pressure with respect to the outside, because it's blowing air out through a door open to the outside. So in this type of case, you're setting up in the hallway. You've got a larger surface area to the outside, because now you've got the wall that was 50 pascals the outside before, plus now you have this wall, which is should be pretty close to 50 to the outside. So you're going to have more leakage through this wall because the blower door is set up in that wall. Adjoining spaces again, adjoining units above and below and to the side will be depressurized slightly. Another option is to depressurize the whole building with multiple blower doors and depressurize the whole, open all the doors to all of the units, and so the whole building is at one pressure, and you can get one number on what the total building is to the outside. You could also, for diagnostic purposes, test individual units. If you set up a blower door or duct blaster in each individual door and have this unit at 50 when the whole building is at 50, that will tell you how much leakage there is from this unit to the outside, because adjoining units will all be at 50, so there won't be leakage between any interior spaces because they're all at the same pressure, and you'll be measuring just the pressure, just the leakage from the outside in that unit. So you could compare upper units to middle units to lower units and get a better idea, corner units to interior units, and you could use that for diagnostic purposes. Whole buildings at the same pressure, only leakage to the outside would be measured through that fan set up in the hallway door. So you may be lucky enough to have doors going out to patios where you could set up a blower door right in to the outside in a unit. You can get creative. This is on a bigger building where they set up blower doors in a window. You can, as I mentioned, you can use the duct blaster fan as a blower door, or you can set up the duct blaster in a window. You don't need to use the flex duct. You can fasten that duct blaster fan right in a panel opening. If you can cut it out of plywood maybe, or some kind of rigid material. Put some weather stripping around the edges and customize it for a window size. And if each apartment has the same window size and the fan is attached directly to that, it's pretty easy move from one unit to another with that system. Or if you do set up in a door with a blower door frame and a panel with the hole in its size of a duct blaster, again, you can pretty easily move that. You could pick up that duct blaster frame with the fan in it, just loosen it up a bit so you can get it out of that door opening, loosen the cam levers, and move down the hallway to the next door with the fan right in the frame. So that makes it pretty quick to move down the hallways and do multiple tests. 2-fan system, 3-fan system. We do have a multi-fan protocol for 2 and 3-fan systems, and basically you do your baseline reading with both fans closed. Let's say we're doing it with a 2-fan system. You'll crank the first fan all of the way up, and if you're not at 50 yet, you'll determine if you need rings on the second blower door. You'll crank the second blower door up till you get to 50. Once you're at 50, you'll take the readings on those two, maybe set them to a long-term average, and once those numbers are pretty steady, then write down your blower door reading. So pretty simple protocol. Or you could use maybe use Tektite for that protocol. So we've got a picture of a 2-fan and a 3-fan system there. Again, that process, you'll have a primary and a secondary gauge for a 2-fan test. Enter the baseline and turn the primary fan all the way up, like I talked about. And then you'll determine which flow ring to use on the secondary one. Bring it up to 50 and add the flows together. Before you start the before you take the rings off on the second fan, you'll want to start that fan running. Otherwise, when you turn when you take the rings off, the blades will turn backwards on the fan. So it's important before taking the rings off on the second fan, get the fan blades moving and get them moving fairly fast before you take the rings off. Otherwise, the blades will be turning the wrong way on that second fan. Then you'll bring it up to 50 and add those flows together once the building's at 50. So software options, we've got a new version of Tektite called Tektite 4.0, and then we've got Tektite Express and Techlog. The new version of Tektite, it's free download from our website, includes the ResNet testing standards, does calculations for ASHRAE 62.2. Tektite Express has a couple of additional testing standards. EN 13829 is been used by Passive House. It's a European standard for passive house testing, and E779 is a protocol that's referenced pretty often, and that requires multi-point testing and testing in both the positive and negative directions. And CGSB is a Canadian General Standards Bureau, and that's the test that's always multi-point test that's always been in Tektite. Tektite Express has a simplified report. It doesn't go into energy savings info or those types of things. So the report is, if you're looking for a simplified report, you might want to try that one out. Techlog II is designed for either data logging pressures over a long period of time. You could use it for CAS testing. And it is designed where you can control up to 24 fans with one slide bar. It will average multiple outdoor references and can monitor interior pressures during the test. So lots of functionality, lots of options. You can set up each channel to measure flows either with a blower or a duct blaster. You could use it to measure envelope pressure, pressures within the buildings, or other types of pressures you may want to monitor, and it can be used for long-term pressure monitoring also. So you can get pretty creative on testing big buildings with setting up multiple blower door fans. We do have data acquisition hardware where you can use Cat5 cable and an 8-port hub, so you could hook up to 8 gauges to the hub and then go to the computer via a USB drive. And then on the other end, there's a 9-pin to Cat5 adapter that you would put on the gauge and then run Cat5. And we've run up to 5,000 feet of Cat5 cable and not had any trouble with the signal. So Cat5 is readily available. So lots of options that way. You can also, if you're doing a 3-fan test, you only need to use 2 gauges because you can set each channel to what you want to use it for. So in this case, in this setup here, we're using gauge 1 on the left for, just like you would for a typical blower door, where one is going to the outside reference channel A and the fan flow on channel B, and then the second gauge is will do the middle fan and the top fan flow. You can set up channel A for flow for the middle and channel B for flow on the top, and you can get by with 2 gauges. And then we've got a controller board, so you can put 3 controllers on one board that way. And we also have a splitter, so you can combine those 2 cables and only run one cable back to the computer. So that makes that setup pretty nice. And then we use a 3 a splitter, audio splitter, so you can control, because you're going to be controlling all 3 fans from the computer anyhow, so you can run all 3 signals off of one DG700. So that's pretty slick. And this is what that Tektite Test, Techlog II test will look like. You can test at multiple pressures, and it will calculate the accuracy and precision of the test, and give you the results based on as many outdoor reference pressures as you want, one on each side of the building maybe. So that concludes our webinar for today, and feel free to contact the Energy Conservatory if you have any additional questions, or check out our website at energyconservatory.com for additional information. Thank you.